Welcome back, everyone. In today's video, we're going to do some more examples of applying the closed interval method. So today's examples, we're going to focus on functions where it's going to require dealing with fractions or the product rule or the quotient rule or that kind of thing. Okay, so here's a function. And we want to try and find the min and max values of this on 1, 3. So we're going to follow our closed interval method. So the first thing we're going to do is calculate the derivative. And just to be clear, how did I take the derivative of 9 over x squared? The way I take that derivative is to rewrite that as the derivative of 9 times x to the minus 2. And so then I can use the power rule, so that is where I got the minus 18x to the minus 3 that I've written over here. So this is our derivative, and we want to know when this is equal to 0. So that says 8x is equal to 18 over x cubed, or this says x to the 4th is equal to 18 over 8, which is 9 over 4. I can take the square root of both sides, which will give me x squared is equal to 3 halves. And then that means that what I have here is x is plus root 3 over 2, or x is minus root 3 over 2. Those are my two solutions to where this derivative is equal to 0. Okay, so now I found all the critical numbers, but remember I'm only supposed to find the critical numbers in the interval, so in particular, this one goes away. Okay, and so my only critical number here is this root 3 over 2. So next, what am I supposed to do? Next, I'm supposed to evaluate this function at 1, this critical number, and 3. At 1, this function takes the value 4 plus 9, which is 13. At 3, it takes the value 4 times 9, which is 36, plus 1, which is 37. And at the square root of 3 halves, I am going to get 4 times 3 halves plus 9 divided by 3 halves. Okay, this being because I'm plugging in here the square root of 3 halves, but then I'm immediately squaring it in both places. So I'm just going to get a 3 halves. Okay. And so this is going to be 6 plus, and then this is also going to be 6. So this is going to be 12. And then for my third step, I just need to find the smallest of these numbers and the largest of these numbers. So this 12, that's the smallest, so that's the min value. And this 37, that's the biggest, so that's the max value. And that's how this is going to go. Okay, so here's a closed interval method question where we have a natural log and a product rule that we have to do. So let's make sure we can follow the steps here. So first things first, I still need the critical numbers. So I'm going to calculate the derivative, which is going to require using the product rule, like that. So f prime of x is 1 times twice the natural log of x minus 3. Plus x times 2 over x, so plus 2. Which, if I simplify it, that is twice the natural log of x minus 1. Now I want to know when that's equal to 0. So I want to find my critical numbers. So that's going to give me twice the natural log of x is 1. So that's going to give me that the natural log of x is 1/2. And which number has natural log 1/2? Well, that number is the square root of e. Okay, remember e to the 1/2 power is the same as square root of e. So this is my critical number. Okay, so that was my first step. I got my critical number. That square root of e, it is in this interval between 1 and e squared. Second, we have to evaluate f of 1, f of the square root of e, and f of e squared. F of 1, and remember we're going back to the original function here, is 1 times, and then this piece is 0 minus 3, so it is minus 3. F of the square root of e, it's going to be the square root of e times 2 times the natural log of the square root of e minus 3. Sorry, that got a little messy. And so this is going to be the square root of e times, and the natural log of square root of e is a half, as we noted. So this is twice a half, so it's 1 minus 3. Okay, and so this is going to be minus 2 times the square root of e. And then f of e squared is going to be e squared times 2 times the natural log of e squared, which is also 2 minus 3. So this is e squared. Okay, so now we have to decide which of these numbers is the largest and which is the smallest. Okay. One of those is a little easier than the other. Namely, e squared is the only positive one, so it's definitely the biggest. Note again, the e squared I'm giving is the output. It just so happens that at e squared, the output is e squared for this particular function. The minimum of these depends on which of these is actually smaller. And probably you're going to need a calculator to decide that. But in fact, if you check, this one is a little smaller than 3. And so the min value is in fact that. And so those are the answers to my question. Okay, so let's find the max and min values of this function on this interval. Now we have to use the quotient rule. So let's take the derivative of g, and let's use the quotient rule here. Remember, the numerator has to be a, so then the denominator is b. So here are my a and b, and a prime and b prime. So now I can write down g prime of x, which remember is going to be a prime b minus ab prime, all over b squared. So filling that in, that is going to be 1 times b, so x squared minus x plus 1, minus a times b. And what I need to know is when this is equal to 0. Now, thing to remember, this is a fraction, so the only way it can be 0 is if its numerator is 0. Which means I can just ignore this piece and just solve the equation x squared minus x plus 1 minus x minus 1 times 2x minus 1 is equal to 0. And that's how I'm going to get my critical numbers. So this is going to be x squared minus x plus 1 minus 2x squared plus 3x minus 1. And so that is going to give me minus x squared plus 2x is equal to 0. And so factoring a minus x out of that, I'll get minus x times x minus 2. And so that means my critical numbers are, in fact, x equals 0 and x equals 2, both of which happen to live inside my interval. Now that I have the critical numbers, I need to evaluate the function at the endpoints and those critical numbers. So let's quickly do that. If I take g of minus 1, I come back up here, I get minus 2 over 3. g of 0 then is just minus 1. G of 2 is 1/3. And g of 3 is 2/7. So now we just have to write down the max value and the min value. So the largest number out of this list is 1/3. And the minimum value out of this list is minus 1. So there's my max, and there's my min. I'll do one last example here of applying the closed interval method. So here we've got a function. And again, in order to find the critical numbers of this function, I'm going to need to use the quotient rule. So I'm going to write down my numerator and the denominator and their derivatives. I can go ahead and write down the derivative. This is going to be a prime b minus ab prime all divided by b squared. Now, it might make my life a little bit easier if I notice that there's an e to the x in both terms in the numerator, and there's also, in fact, 2 e to the x's in the denominator. So, in fact, I can cancel these e to the x's with one of my e to the x's from the denominator. And so that will leave me with 4x plus 3 minus 2x squared minus 3x plus 3 over e to the x, which is minus 2x squared plus x plus 6 over e to the x. Now again, I really only care where this is 0, so I can go ahead and set this numerator here equal to 0. And go ahead and try and find my critical numbers. So I think this factorization works. And so my critical numbers here work out to be x equals minus 3/2 and x equals 2. However, note the x equals minus 3/2 is not in the interval. And so as a result, this is the only critical number I have to deal with. I'll carve out some space up here. I need to find g of 0, g of 2, and g of 5. I'll go ahead and record those over here. These are our values of the function at these points. Okay, and so now I need to pick out the biggest and the smallest. Well, there's only one negative one, so that one's definitely the min. And as far as the max goes, we can type this into a calculator if we're not sure, but in fact 11e to the minus 2 is bigger than 62e to the minus 5th. Alright, and so that gives you a plethora of examples of applying the closed interval method that you can look through as you do the homework and look at all these functions of various sorts. In the next section, which is also the last section, we're going to talk about the first derivative test, and how to use the notion of a derivative to determine where a function's increasing and where it is decreasing. But that's all for today. I'll see you next time.